Okay, so here we go. We're going to cover arrow notation and our introduction to rotations assignment. You guys should add these onto the back of the assignment that we have in this specific place that I'm going to show you right now. Okay, we're looking for the last page, again, all the way at the end of the assignment. We have some places to put the arrow notation. So we got the rotations 180, 90 degree clockwise. They go right here. Okay, so in this spot, for instance, you guys would add that a rotation 180 about the origin means that I have to take x, y, and turn those into negative x and negative y. Okay, so in class we studied that means that we have to change the sign of both the x and y coordinates. Okay, and likewise you guys should write the other two transformations on your paper, okay, just like we did in class. So go ahead and write those two down. Okay, now we saw that in both clockwise rotations that go 90 degrees, we end up switching the numbers that we had for y and x, okay? But in the clockwise rotation, okay, we notice on the one where clockwise goes from the top to the right, okay, we end up changing the sign of the one on the right. And then in counterclockwise, where we end up going from the top to the left, we end up changing the sign of the number on the left side. So this is the way that we'll be doing our rotations. We'll use this to get through most of the work today. So let's just jump in and get the practice going. So you guys can see some of the answers are projected. So there's more than one way to do this. All right. In this video, I will not be showing you really the mechanical way because I'm not going to, take a video of me moving and spinning the paper around. If you need me to show you the physical, mechanical way of solving this problem, then, just stop by after school, come to office hours or something, and I can show you. All right. In the video, I'm going to stick to the numerical method. So this is what you got to use. Okay, we're going to put the coordinates of each point. So the coordinate of S and this one, all right, we got 1 and negative 3. All right, for T, I have to go right 2 and down 4. So that's 2, negative 4. For U, I have to go right 3 and down 4. So that's also a negative 4. And then for R, I have to go left and right 0, right, because it's right on the y-axis. So that's the x coordinate 0, but the y coordinate is negative 5 because it's down 5. So what we just did is we labeled all of our points, and we got to understand that a rotation 180 about the origin means that I have to follow this arrow notation, right, where I take my x and y and we change the sign of them. Okay, so to get the value of S prime, T prime, U prime, and R prime, all we have to do is change the sign. So let's go put those numbers in. Okay, the positive 1 is going to turn into a negative 1. But the negative 3 becomes a positive 3. The positive 2 becomes a negative 2, but the negative 4 becomes a positive 4. So we just change the sign of both of them, right? The positive 3 is negative 3. The negative 4 becomes a positive 4, right? 0 will become negative 0, so we just leave it at 0, all right? And negative 5 is just 5. We change it to a positive. Now if we go put these points down, we'll be complete. All right, so to put S prime, I'm going to go left 1 and up 3, and that's S prime. Now for T prime, I'm going to go left 2 and up 4. So that's T prime, prime, right? And then for U prime, I got to go left 3 and up 4. So U prime is right there. And then to get R prime, I got to go in the middle, right? And I just go up 5. So that's my R prime, okay? I'll do that in red so it stands out more. And we get to connect these points the right way. Okay, so be patient. And that would be the way you want to rotate the shape. Okay, so do it with the numbers. Again, the big thing is the arrow notation. Okay, it's really simple to mess something up. It's easy to say, okay, to look at the negative 3 but write a positive 3 on accident or something. Okay, so just pay attention to the negatives because that's what we're doing here. Okay, so number 1 works like that. That's how it is. Now, I did give you guys the answers to the odd problems, so I'll be doing some of the even ones on here. All right, so for number 2, again, we probably did this one in class, but this video is also for people that were out. So, just deal with it. Fast forward if you already got this one done. All right, so W is negative 4 and negative 5 because I got to go left 4 and down 5. For X, I got to go left 3 and down only 2. But for Y, I got to go left 1 and then down 5. Okay, so we can see all of our coordinates ended up being negative in this case. And because we're doing a rotation 180, right? this word is what tells me that I have to use the transformation, right, of negative x and negative y. This is where we change the sign of both of them, right? So we're just going to change the sign of our coordinates, right? So let's go do that. Move those down a little bit. So we got w, okay, I just change the sign. So negative 4 becomes positive 4, negative 5 becomes positive 5. Got that prime mark got a little long. So now negative 3, positive 3, negative 2 is 2. And then y prime, we're going to turn the negative 1 into a positive 1 and the negative 5 into a positive 5. So, I mean, I just want to echo that, like, you might think that this means that x has to be negative, and that's not what it means, okay? This means we have to look at what x used to be, and we have to change the sign, right? Because, think about it. What does negative 1 mean? That just means 1, all right? So that's all we're doing here. That's what it means to change the sign of something, all right? So now I just got to go put those points down. So I'll go do that in blue. Okay, with the blue points, we'll drop them down. So for w, I'll go over 4 up 5. That's w prime. X is going to be over 3 up 2. So that's x prime. And then y is going to be over 1 up 5. So that's y prime. And then just connect your dots, and we have this triangle. And that's all you need. Okay, this one will be done. So number 3, the answer is in your answer key. So I'm not going to let the video get too long by doing number 3. But we'll take a look at number 4. So in this idea, again, like I told you last time, just get all of the points, like H, I, J, G, all right? And just put them down, okay? So H is 0, 2. I is 2, 3. Right, to get to J, I have to go right 3 and down 1. And to get to G, I don't go left and right, so that's 0. But I just go down 1. Okay, so now let's get H prime, I prime, J prime, and G prime. Well, we know that we're doing a 180-degree rotation. So I'm going to write the arrow notation one more time so you guys see it. And it just means to change the sign of the x and y values. Okay, so 0 turns into negative 0, stays the same, but 2 turns into negative 2. Right? The positive 2 turns into negative 2, positive 3 turns into negative 3. You might want to check your understanding right now. This would be a good moment for you to think about what I'm going to write next, okay? Go ahead, think about it. What's going to be the coordinates of J? We'll change the positive 3 into a negative 3, and we'll change the negative 1 into a positive 1. Okay, 0. We don't have to write negative 0. It's just 0. Okay, negative 1, right? We change the negative 1 into a positive 1. So now we just go drop these points down. We'll have the whole thing complete. To do H prime, it tells me I just have to go down 2 points. Call that H prime. I prime tells me I got to go left 2 and down 3. So that's my I prime. Then J, it says left 3, down 1. All right, that's J prime. And then we got G says go just down. That doesn't make sense, does it? Oh, up 1. My fault. Yeah, there we go. So right here, G prime. I got lost for a second. So that happens. So always just double check. You might be looking at like 1 per second. I was looking here instead of looking at that. And then when you get so procedural, you might just be moving your pencil. So always, think about what you're doing, especially at the end of the problem. Always go back and read it and make sure that you did what you were supposed to do actually. All right, so this is a complete 180-degree rotation. We see that that's not that stressful. You just got to change the sign of a number. So again, the negatives become positives and the positives become negatives. All right, so looking at the 90 degrees clockwise, number 5, again, you guys have the answer in your answer key. So I'll do number 6 together with you. So in this case, we have a 90 degrees clockwise rotation, and I really do want you guys to already start to memorize these things. So try to test yourself. Which one do I change the sign of? The one on the left or the one on the right? Which one that I want you guys to use to determine that, right? So draw a little clock, right? And think about it. Clockwise is from the top to the right. So which one do I change? Change the one on the right, okay? Try to connect those 2 neurons in your brain, okay? Clockwise, we'll change the coordinate on the right after we switch them. Okay, so we got JKL over here. We'll do these points, all right? J is left 3, down 5. So that's negative 3, negative 5. K is left 1 and up and down 0 because it's right on the x-axis, right? L, I got to go right 1 and then I have to go down 4. So now we'll get J prime, K prime, and L prime. So to do this part, what we do is we take the numbers and just move them, and we'll change them after we switch them. Okay? So the negative 5 goes here, and the negative 3 goes there. Notice that these two numbers just switch places. Okay? But now I got to change the sign of the one on the right. So I'm going to take this 3 and turn it into a positive. Okay? So there's one way to do it, or you can just erase the negative. Okay? So same thing, I'm going to put the 0 here and the negative 1 there, and then I change the sign of the one on the right. So again, I either leave it as a plus or I just erase the negative sign. Okay, we'll put a negative 4 right there, and we'll put a 1 here. Again, we just switch those two numbers, right? They just switch, and then I change the sign of the one on the right, so that's, our points are already there. So to plot these, it says to do J, I got to go left 5 and then up 3. So that gives me my J prime. Then K prime says to go left and right 0, but just go up 1. So that's K prime. And now L, it says to go left 4 and down 1. So that's my L prime. And now we got our shape. Okay. Now you'll notice that if you take any of these points that you got, right? Take K, okay? Take K and K prime. If I connect those to the origin, what kind of angle do I get? All right? Notice that we get a 90-degree angle, okay? And the K has just been rotated 90 degrees about the origin, right? It's like if this point got moved and got spun, right, around the origin, but it still stays the same distance away. That's what a rotation is, right? So that's all that happens, okay? All of these points are moving that same amount. So let's go try to do, again, number 7 would have been in your answer key. So number 8 is one that we'll do together. So in this example, we again have a clockwise rotation. So recall your arrow notation. Make sure you know what to look at, okay? We take the Y and the X, and which one do I change? Change the one on the right. All right, that's the one we change. So we got our V, W, X, okay? What are our coordinates of these points? All right, we got the V is left 3, up 2. The W is left 2, up 5. And the X is left 0, up 2, right? So it stays right there. Okay, so now let's get our image. All right, our images of each point, right? So that was the pre-image. Again, remember, we got that word, the pre-image. And the one with the prime is the image. So we go put our numbers in there, okay? Again, it says just take your X and Y and switch them. So the 2 goes there, the negative 3 goes here. Okay, but then I change the sign of the 1 on the right. Okay, I'm going to take the 5 and the negative 2. They switch, okay, and then I change the sign of the 1 on the right. All right, the 2 and the 0 go there, and then I change the sign of the 1 on the right, but negative 0 is just 0. So, we don't ever really deal with that. Okay, and again, like I said, we don't really want to write the positive. You can just erase the negative, right? So those are our points, okay? To put V, I go right 2, up 3, and that is V prime. All right, W, I go right 5, up 2, that's W. All right, and then to get to X prime, I got to go right 2 and up 0, so that is my X prime. All right, again, don't forget to actually connect the dots and label them as the primes and everything, okay? Look at what we see again, okay? If I take X and X prime, and if I connect them with the origin, what kind of angle do you see? We see a 90-degree angle, and it went clockwise. See, X went this way to become X prime. All right, so again, that's all we're doing with our rotations. The numbers are just going to get transformed a little bit, right? So for number 10, I'll project the answer at least on this one, and you guys can deal with it. All right, the answer for 10 is right here. Understand the way that you want to do these. I'm not going to give away probably the rest of the even, so I'll leave a couple of blanks so you guys got to think about something. All right, but number 10, you guys could at least see an answer. All right, so 11 is a counterclockwise, and we're getting close to the end of the video. So rotation counterclockwise is where I take my x, y, and that turns into y and x. All right, but which one do I change in this one? Well, remember, counterclockwise is when I go from the top, but to the left. All right, so this is the one where we change the one on the left. All right, so try to connect those two ideas, right? We got D, E, F. So D is left 3, up 3. E is left 4, up 5. And F is left 5, up 2. So now to get through this part, we're going to get D prime, E prime, and F prime. So now what we get is this idea where we switch the two numbers. So 3 goes there, negative 3 goes here. Okay, but now I change the sign of the 1 on the left. All right? The 5 and the negative 4 switch places, change the 1 on the left. The 2 and the negative 5 switch places, change the 1 on the left. All right, we change the 1 on the left again because counterclockwise is going from the top to the left, so we'll use that to remember. Okay, so let's go drop our points. It says that D prime is left 3, down 3. So that's D prime. Okay, then it says that E prime is left 5, down 4. So that's E prime. And then it tells us that F prime is left 2, down 5. So that puts us around here. Okay, so just connect your dots and you'll have your rotation correct. Okay, so we got a couple more examples to do. I think maybe like 4 more examples. Okay, so for number 12, I told you I'll leave you guys with a couple more to do. So number 12, I'm not going to put the answer up. Okay, you guys got to get through that one. All right, number 13, you guys had the answer, so you guys should be able to see it on your answer key anyway. But right here, we got this one. All right. So now for 14, again, I'm gonna leave that one blank. Okay, you guys got to do something. Then there we go, we made it. So 12 and 14 are for you guys to do. So show me if you can't figure those out, but I think you guys can do it. Okay. Now we did this one in class, right? This version of this problem. So we'll cover it at least. All right. To do these problems, you want to understand the way they work. Okay. If the statement is true, then you select the statement is true. Okay? So in this case, this statement is very true. If we look at it, it says a rotation 90 degrees clockwise about the origin. So if this is the origin, the blue point stays still. And let's say I take this point and rotate it 90 degrees clockwise. So that means I went 90 degrees that way, right? And then let's say I go another 90 degrees clockwise, okay? Is this thing, right? Notice that the red ended up right here, yeah? Is this thing the same as a rotation 180 about the origin? Well, let's try it. If I go 180 about the origin, it doesn't matter which way I go, right? So what if I go that way? Okay. Do the red and the blue arrows end in the same place? Yes, they do, right? And so the point is for you guys to say that this is true, okay? All I'm checking is, can you realize that 90 and 90 in the same direction, okay? That's the key, is that they both went clockwise. All right, since they both went clockwise, we can add them up to 180. Okay, so this one would be the statement is true. Okay, and also, none of these could have been counterexamples because none of these would make it true. All right, none of these would prove that this thing is false, right? All of these examples would move 90 degrees clockwise, 90 degrees clockwise, and it would be the same as a 180. Okay, so when something's true, there are no counterexamples. All right, so let's go take a look at what a counterexample actually is. All right, so for 16, we have an example here to take a look at. Let's draw a little picture. It says if a point is rotated 90 degrees clockwise. So let's start up here and go 90 degrees clockwise. Okay, and then rotate it 180 degrees clockwise. So notice we went the same way. That actually matters right now, that we had to continue going the same way we started. So the clockwise actually mattered this time. Okay, now what do I do? Well, what's going to happen? Where are we at? Okay, if I do the next one, it says that then its coordinates follow the transformation xy turns into negative yx, right? So our rotation that we have down here this one represents a counterclockwise 90 degrees, right? So let's think about what this is trying to tell us. This is telling us that this red motion that we've done, right, would be equivalent to a 90 degrees counterclockwise. It's telling me that if I do 90 clockwise and 180 clockwise, that that's the same thing as doing 90 degrees counterclockwise. So what if I start here at the top and then go 90 degrees counterclockwise? Okay, right, top to the left. Does the red arrow and the blue arrow end in the same place? Look, they end in the same exact spot. So that means that this one is true. It must be true. Okay? So we'll take a look at 17 and 18 to make you guys think a little bit more. Okay? Now when we look at this one, we see all I'm trying to get you to do is like draw a little picture and experiment to see whether or not this thing is true. We're not just going to be confused and boggled because we have to read something. Okay, so read through it. If a point is rotated 90 degrees clockwise and then 180 degrees clockwise, okay, so let's do that. 90 degrees clockwise, right? And then 180 degrees clockwise. Okay, so we still keep going that way. So is that the same thing as this transformation? Okay, so what's this mean? Well, notice that the sign got changed on the right. So this is a 90 degrees clockwise transformation. Okay, so we noticed that this transformation, right, started all the way here and ended right here. Okay, but if I do a 90 degrees clockwise, that starts at the top and goes to the right. So does this point, does the blue arrow end in the same place as the red arrow? Well, no, the red arrow ends right here, right? The red arrow ends there, but the blue arrow ends over here. So this is not equivalent. So I know I can cross out this is true right away. Okay? Now we want to find the counterexample. Okay? So to find a counterexample, I need to find a point that will get rotated 90 degrees clockwise and then 180 degrees clockwise, but that does not do this. That is not the same as a 90 degrees clockwise. Okay? So why is the reason that I can't use the origin then? Okay? Because the origin is the point that we're rotating about. Notice it says we're rotating about the origin. So it means that point will not move. So that means if I try to rotate the point 0, 0 around the origin, I'm just going to get 0, 0 again. So I won't get a counterexample because it'll show me the same thing I had. So I can cross out the origin. Okay? Now if we take a look at B, we say B is x factorial, and this is something that has nothing to do with any points at all. So this one is irrelevant, and we should cross it out, okay? Because x factorial is not a point, okay? A thing that is a counterexample here would have to make the hypothesis true, and that means it has to be at least a point, right? So this is our answer, and we can go see why this is true in a second. Let's go do the actual problem and think about this, right? If I have my xy axis, okay, and I put the point 2, 3. All right, there it is. There's the point A. We'll call it A. And there's 2, 3. All right. If I take this point and rotate it 90 degrees clockwise and then 180 degrees clockwise, where does it end up? Right? If I move it 90 degrees clockwise, right, about the origin, then here we go. We got a point there, and I got to move it there, right? So it's going to move this way 90 degrees. Okay? So we know that to rotate something 90 degrees clockwise, right, would mean to switch the x and the y, and I change the sign of the one on the right. So 3, negative 2, that's this one, right? So now we would see this point lined up with 3 to get to that one, okay? Now, if I do this, again, rotated 180, then I got to take this all the way over here to this side, and that's going to get me to the point where I got to change the sign of those two numbers, right? So the x turns to negative 3, and the negative 2 turns to a positive 2, okay? So let's see that. Our point A prime prime is right there. Now, is that the same as a 90 degrees clockwise turn of this same point? It's not, okay? Because if I take this point and move it 90 degrees clockwise, I get this one, okay? So since these 2 points are not the same, this has been our counterexample, right? This point, 2, 3, shows that this statement, right, this whole statement inside this box that I'm drawing, this statement cannot be true, okay? So draw a picture to make sure you understand that, But let's try to break down another example for 18. Okay. So on 18 it says that we got a point reflected across the x-axis and then reflected across the y-axis. And we want to see if that is the same as a 180-degree rotation about the origin. Okay? So what you should do is break that down. I mean, think about it. If I take a point and then reflect it across the x-axis, what does that mean? Well, we've seen this, right? That if I take a point and reflect it across the x-axis, all right? So this right here, reflect across x, all right? This is something that you would have wrote on the back page of your thing if you were in class, okay? When I reflect across x, that turns xy into x negative y, right? So that changes that sign. But if I reflect then across y, then reflecting across y, that changes my x-coordinate. So now my x-coordinate would be negative. Okay, but notice that that is exactly the same thing as a rotation 180, right? Because if I do a rotation 180, okay, then we got negative x and negative y. So notice how they both end up with the same thing. This ends up with negative x, negative y, and this ends up with negative x, negative y, okay? If you wanted to test it like geometrically, looking at the points, you can say, okay, if I reflect this across the x-axis, right, then a prime will be right here, right? And then if I take a prime and reflect it across the y-axis, then a prime prime will be right here. And look at what kind of degree this made, right? With the origin, that made an angle of 180 degrees, okay? So in this case, I hope you guys can see the statement is true. Okay, so for these problems, you're going to have to show me that you know what these words mean and that you're reading them by drawing pictures and thinking about them. All right. So for 19, you guys can think about this one on your own. I think you guys have the answer in your notes, okay? And I believe on number 20, I might have made a mistake, and I think I gave two correct answers on this one, right? So let's talk about this, and this will be the last thing on this video. So if a point is reflected across the y-axis, then its x-coordinate does not change, okay? Is this true or not true, okay? Well, it's not always true, but it's true sometimes, right? If I put a point right here, okay, and let's say that's the point A equals 0, 2, right? So if I am going to take this and reflect it across the y-axis, well, think about it. It's on the y-axis. So if I reflect it across the y-axis, then it doesn't move, okay? So I mean the A prime is still 0, 2. In which case, its x-coordinate did not change, okay? And so any point that is on the y-axis would be an example of this being true, okay? But we don't want an example. Not an example, we want a counter example. We want one that proves this false, not one that proves it true. So what we're looking for is something that proves this part, the conclusion, false, okay? I need to find a part that makes this red thing that I'm highlighting true, though. So I need to find a point that does get reflected across the y-axis, but that if I do that, gives me a coordinate that does the opposite of this. What's the opposite of does not change? The opposite is that it does change. So for me to produce a counterexample to this, I need to find a point that when I reflect it across the x-axis, the x-coordinate does change, okay? So we'll go do that really quick, and you guys should see what the answer is in a second. Like I said, I accidentally put two correct answers here, so my fault about doing that. Okay, let's start off with A. Okay, so we'll start off with 3, 0, okay? If I put the point 3, 0 right there and reflect that across the y-axis, right, and that's A, then A prime is going to be on this side, right, at -3, okay, and that would be my A prime. So notice that, look, this point got reflected across the y-axis, and its x-coordinate changed from +3 to -3. So this point is a counterexample, okay? This point could also be a counterexample, all right? So I accidentally made two of them. But we know this statement is not true. It's not always true. This statement is only true sometimes. This statement would only be true for C. Okay, so C is an example, but it's not a counterexample. Okay, so we would not want to pick C. We should cross this out because, again, we don't want examples. Here we're looking for counter examples. We want something to prove this whole statement false. Okay, and to do that, we want to find something that makes the hypothesis true and the conclusion false. Okay, so I'll leave the video there. Good luck to everybody getting your homework done. I'll see you guys next week.